Hello everyone, welcome back to our YouTube channel World of Software Testing. So in this lecture we'll discuss about second level of software testing, that is integration testing. So how the integration testing is carried out we're going to see in this lecture. So these are the four levels of testing. Out of this we have already covered unit testing, second one integration testing, third one is system testing, and then acceptance testing. So let's discuss about integration testing. What is integration testing? So integration testing is also called as a second level of software testing, and to be done after the unit testing or the component testing is done. Integration testing, also known as integration testing, integration and testing, that is INT. So it is a type of software testing in which the different units or modules or components of the software application are combined and tested as a group. However, these models may be coded by different programmers, and once all the components or the modules are working as expected independently, then we need to check the data flow between the dependent modules is known as integration testing. So what we are doing in component testing, so we are testing each and every component individually, and in integration testing we are combining those different components and testing them integrally. So this is integration testing with a combination of different components. So this is component testing versus integration testing. So let us understand this with the help of example. So we have these three modules, module A, module B, and module C. So in the first, you can see this is a component system. So this is component 1, this is component 2, and this is component 3. And here they all are bind together, which is and then they are going to be tested. This is integration testing. So let's say user A, this user A, and the present account balance for this is 10,000 for user A. Then user B, present account balance is, let's say, 5,000, and let's say user A wants to transfer 1,000 rupees to user B. So let's say, sorry, this is the user B, okay, and he want to transfer 1,000 rupees to user B. So we do usually on the banking application. This is a banking example, we can say. Then log into the banking application with user A as a username and password. Select user B account details. Enter 10,000. Not 10,000. We are going to transfer 1,000 rupees. That is amount to transfer. And then send. Send from user A. Right. This is the user A. So enter the OTP which user A gets on the mobile number, and then click on OK. The confirmation message must be displayed as 1,000 rupees debited successfully, or whatever the message the application has set to. And then log out the user A account and log in with the user B username and password. So first what we have done is we have logged into the user A, log in with user A, and then transfer 1,000 rupees to user B. And then after that just log out from the user A and then log in with the user B username and password. So user A balance must be 6,000, that is plus 1,000, that is 6,000 rupees must be the balance for user B. So if this is occurring, we can say that integration testing is successful. And if it is failed, that is if you are not seeing this balance, that is 6,000, then you can say that integration is failed because it's not working as expected. It should be 6,000 there in user B's account. So before performing the integration testing, again testers must have our test cases ready with positive as well as negative scenarios. Generally we perform integration testing only after the completion of functional testing on this each and every components. So again let's take one more example of Gmail application which we discussed in our previous lectures as well. So here in this example you can see username, password, sign in button. So these are the components available on this page. So basically we perform functional testing on the username field, password field, sign in button, the check boxes. You can see that these are the check boxes available here, and all the features, and then once login we can perform the integration testing. So here we need to perform the functional testing on each and every fields. So like for username, we are performing input domain testing, and various types of testing we perform on these checkboxes as well. And then once we click on the sign in button, the user gets login, and then we can perform the integration testing. So let's say assume user A is logging into Gmail application. So let's say here I will write user A is logging into the Gmail application. Then he will compose the email. Let's say compose email, and then write some body to that email, and then close from the window. The email must be saved in the draft box. So you must be aware of this functionality. So whenever you are just closing any body or any mail without saving it, it must be saved in the draft box. Then again open the draft and enter the email ID into field, that is for the user B, and then click on send and log out from the Gmail. So again login again with the user B. So here what we are doing is we are sending the email, and then you are just log out and then log in with user B, right? So and check the inbox. So the sent mail from user A must be in user B's inbox. So message sent by user A will be there in the inbox. If user B has marked the user as spammed, then the message should not be in inbox, but it should be in the spam box. So if user B has marked the user into a specific folder with rules, the message from user A must be in the specific folder user B has chosen, right? So it should not go into the spam box or inbox. It should go to the specific folder. So the main function or goal of this testing is to test the interfaces between the units or the modules. So let's understand the different types of integration testing. So here let's discuss about these types first. So here I have mentioned the technical team, because there are different types of testings are carried out by the testers and the developer. So the technical teams, which includes tester as well as the developers. And then what the testers do is, testers do this type of testing. First one is the incremental integration testing, and then second one is the non-incremental integration testing, or also called as Big Bang testing. And inside developer performs two types of integration testing. First one is the front end approach using a call function, and then the back end approach using a join query. So we are not going to discuss about this in detail. We'll just discuss about the integration testing related to the testing point of view. Okay, so the testers having incremental integration testing, and again which classified into the top down approach, bottom up approach, and the sandwich or bidirectional approach. So this we will see one by one. So basically the integration testing is performed by both the developers as well as testers. So testers do this incremental and non-incremental testing, and developers do this using front-end approach and the back-end approach. So first discuss about the Big Bang testing. So the Big Bang testing is an integration testing approach in which all the components or modules are integrated together at once and then tested as a unit. So you can see here in the diagram the module A, B, C, D, E. These are integrated together and then tested as a unit. So it does not include integrating the modules one by one. So one by one integration is not allowed in the Big Bang testing. So we need to combine all the modules together and then test it as a unit. So if any issue is detected in completely integrated module, then it becomes very difficult to find out which model has caused the issues, because we are having a lot of modules inside any application. Then if we are integrating them as a complete modules, then it becomes very difficult to find out which model has caused the issue, right? Because it can be this, it can be this can be causing that particular issue. So it's very difficult. So Big Bang approach is very time consuming process of finding a module which has a defect itself, as that would take time, and once the defect is detected, fixing the same would cost high as the defect is detected as a later stage. So this is the main disadvantage of Big Bang testing. So let's discuss about some of the advantages of Big Bang testing. So this is only convenient for the small applications, because as we mentioned, we need to test as a unit with combining all the modules. So it's very difficult to find out the module which is causing the particular issue. It's ace of identifying errors in such systems, saving time and speeding up application deployment. Okay, so let's move on to the disadvantages now. So disadvantages of Big Bang testing: difficult to find out the module which causing the issue or defect. So again, this is the similar point we have discussed already. As the integration testing can commence only after all the modules are designed, the testing team will have less time for the execution in the testing phase. This is again one of the drawback of Big Bang testing. Given the sheer number of interfaces that needs to be tested in this approach, some interfaces linked to be tested could be missed easily. Then testing takes place at once only, which thereby leaves no time for critical module testing in isolation. Due to simultaneous testing, high risk critical modules and peripheral modules dealing with user interfaces are not tested on priority. So these are the disadvantages of Big Bang testing. So let's move on to the incremental approach. First we'll discuss about the bottom-up approach. So you can see the diagram. First one is the main module, then these are the sub modules M2 and M3, and then M2 having sub modules M4 and M5, and again M3 having sub modules M6 and M7. And now we are going from bottom to top. So this is a bottom up approach. So the bottom up integration testing is also called as bottom to top approach, and it is the opposite of top down approach. So it involves testing the lower level modules, that is sub modules first, and then gradually progressing incrementally to the higher level modules. So here first we are testing the sub modules, then we are moving upwards to these sub modules, and then moving to the main modules, that is a top module. So that's why it is called as a bottom up approach. So the first sub modules M4, M5, M6 and M7, so this will be tested first, are already developed, and M1, which is the main module, is under deployment. These tested sub modules are then further used to facilitate the testing of higher level modules. So let's say for example M4 and M5 will be used to facilitate the testing of M2 module, and then M2 and M3 will be facilitated to test the M1 module. It's a higher level module. So in this diagram of bottom up approach, sub modules M4, M5, M6 and M7 will be tested first. Then these modules are used to facilitate the testing of M2 and M3 modules, and then these are used to facilitate the testing of M1 module. Means M1 will be tested at last. So in this case, modules M4, M5, M6, M7 are the lowest modules which are unit tested. Module M2 and M3 are not yet developed. The functionality of module M2 and M3 is that it calls the modules M4, M5, M6 and M7 as the module M2 and M3 are yet to be developed. We would need some program or simulator which will call the M4, M5, M6 and M7 modules. These simulators programs are called as drivers. So as this M1 and M2 and M3 are under development, so these are not ready for the testing. So if you want to call this M4, M5, M6 and M7 from M2 and M3, we would need to have some simulator or some program which will call M4, M5, M6 and M7 modules. These programs are called as drivers. So drivers are basically dummy programs which are used to call the functions of a lower module. So in the case when the calling function does not exist. The bottom-up technique requires module driver to feed the test case input to the interface of module being tested. drivers are basically written in the XML language. So let's understand this with the help of example, how these drivers works. So here we have two modules, M2 and M4. So let's say this is a M2 and this is M4, and we want to test the module M4 which is developed. So this M4 is developed and M2 is yet to be developed. So here we use driver as a dummy code or a fake code in place of M2. So here we are using a driver as a dummy code or a fake code in place of M2 module, which is used to test the lowest module M4. So as this is not ready, we are creating a driver, we are creating a dummy code to have a similar functionalities as M2 to test this M4 module. So we pass the driver to M4 module as a request and get the response from the module M4 as a response. Then we do the comparison between the request and the response, which is called as XML parsing. So if response is expected, then we can say that M4 is working as expected. So let's say in this example, we are providing input A and B, right? So we are providing input A and B to this M4, and if we are getting this result, let's say A we are providing as 2, B we are providing as 4, then 2 into 4 is 8. So if we are getting a response as 8, then we can say that M4 is working as expected. So in this way the driver is working. The advantages of bottom-up approach. The identification of defect is quite easy in terms of bottom-up approach. Less time is needed for troubleshooting, since the testers don't have to wait for a module to be available for testing. So because we are using the driver as a dummy program. Let's discuss about some disadvantages. The critical modules are tested last, due to which the defect can occur. There is no possibility of an early prototype. Testing all modules can take a lot of time, so there may be delays in releasing a final product, and testing can be complicated if the software consists of multiple low-level units. So if we have this multiple layers here, so let's say here M8, M9, M10, M11 and so on, then it will be very difficult and it's complicated if this consists of such multiple low-level units. So these are the disadvantages of bottom-up approach. Let's move on to the top-down approach. So here this is the reverse of bottom-up approach we have discussed. So now here we are going from top to bottom, so like from main module to the sub module, and in this first main module will get developed, and then after that the sub modules, and then sub of sub module you can say. The top-down integration testing is also called as top to bottom approach, and it is the opposite of bottom-up approach. So it involves testing the top level modules, that is the main module first, and then gradually progressing incrementally to the lower level modules. So first main module M1 is already developed, and the sub modules M4, M5, M6, M7 are yet to be developed, as well as this M2 and M3. Only the top level modules is unit tested in isolation. After this, the lower level modules are integrated one by one. The process is repeated until all the modules are integrated and tested. So the higher level modules are tested first, and then the lower modules are tested and integrated in order to check the software functionality. So we are going from top to bottom here. So in this diagram of top-down approach, main module M1 will be tested first, then the testing of M2 and M3 modules, and then the last modules M4, M5, M6 and 7 will be done. So in this case, testing starts from module M1, which is the topmost module, and then the module M2 and M3 are integrated one by one. As the module M2 and M3 are not yet developed, so here as well we would need to have some temporary or dummy program to test the topmost module, and this program in this case is called as Stub. So in case of top down approach, we need to have a dummy program which is called as stub, and if we are dealing with the bottom up approach, then in that case that dummy program is called as a driver. Okay, so because the driver is used to test the lowest module, and then top down, in case of top down approach, the stub is used to test the upper module, we can say, or the topmost module, we can say. The stubs are basically the dummy programs which are used to call the functions of a topmost module in a case when the lower modules are not available for the integration. So with the help of stubs, even if the lower modules are not available for integration, we can test the topmost module. So again, in this case, let's understand how stubs works. So here again we have the M4 module. Sorry, this is the, let's say this is the M1 module. This is something wrong. So M1 module, and this is a, we can consider M4 as well, no problem. So this is the topmost module, you can say. This is the topmost, and this is a bottom, right? So now we need to test this one. Need to test, right? So now this is not yet developed, and this is developed. So here instead of this M4, we are using the stub or the dummy program to call this topmost module calling, right? So here we have two modules, M2 and M4, and we want to test the module M2. Sorry, M1 actually, I'm okay, M1, and then M4 is not yet developed. This is not yet developed. So here we use this stub as a dummy code or a fake code in place of M4 module, which is used to test the top module M1. So we pass the inputs or request from, this is, you can say, request. So we are getting the request from this M1, that is input A and B. So this request is actually coming from the M1 module to the stub actually, and then stub have the dummy program which provides the result in terms of M4 module. So again, once we get the request from M1 to stub, then the stub will provide a response as a, let's say again 2 and 4 as a and B, and then it should provide the response as 8. So again, if the response is as expected, which can be compared with the help of XML parsing, then we can say that M2 is working as expected or M1 is working as expected. I'm doing a mess here. So M1 is working as expected. So in this way the stubs works. So let's move on to the advantages of top-down approach. So it's easier to identify defects and isolate their sources in terms of top-down approach. It is possible to create an early prototype. The testers check the important units first, so they are more likely to find critical design flaws. So these are some of the advantages of top-down approach, and then let's discuss about the disadvantages of top-down approach. The examination of lower level modules can take a lot of time, so testers may not test them adequately or completely. So when too many testing steps are involved, the testing process can become complicated. So we have completed bottom up approach and top down approach. So let's discuss about the last one, that is a sandwich or bidirectional approach, or also called as hybrid approach. The sandwich approach testing combines the top down and bottom up approaches. So it uses both the stubs and drivers. In this process, the top level models are tested with the lower level models, and lower level models tested with the higher level models simultaneously. So here there is nothing like we are testing the bottom models first or testing the top models first. So we can do both. We can test lower level as well as the higher level models simultaneously. So there is a possibility of occurrence of defect because each module interface is tested. This is rarely used approach in the software testing. So let's see some of the advantages and disadvantages of sandwich approach. So advantages: preferable for testing huge programs like operating systems or other long-term applications. And then the disadvantage is it is complex and quite costly. A higher level of precision and skills are required for this kind of approach, sandwich approach. So thanks for watching this video. Hope you have learned some of the things related to the integration testing. So if you like this video, please do subscribe our YouTube channel and click on the bell icon to get the latest updates. Thank you so much.